In this episode, we're going to look at an Inter-VLAN routing challenge. I'll show you how to do it, and we'll talk about the concepts along the way. In this activity, we're going to demonstrate and reinforce the ability to implement Inter-VLAN routing, including configuring IP addresses, VLANs, trunking, and sub-interfaces. Greetings to all my tech heads out there in the KevTechify nation, and if you're new here, welcome. This episode is part of my series on configuration examples for the CCNA. I'm Kevin here at KevTechify. Let's get this adventure started. Inter-VLAN routing challenge. I have our packet tracer file open. On the left side, I have our work area, our topology. This is where we're going to do our configurations. On the right side, I have our instructions. This is the packet tracer activity window that opens when we start up our packet tracer file. I don't have the Word document open because there's no questions to answer. There's no answers to save for this packet tracer file. We have our addressing table right here. We have all of our devices, all of our sub interfaces, IP addresses, subnet masks listed out for us. We also have a table here of VLANs and port assignments. What VLANs number it is, what's the name is, and then what ports on the switch are they assigned to. Here's our scenario. In this activity, you will demonstrate and reinforce your ability to implement inter-VLAN routing, including configuring IP addresses, VLANs, trunking, and sub-interfaces. Instructions: configure the devices to meet the following requirements. First requirement, assign IP addressing to R1 and S1 based on the addressing table. Up here's our addressing table. We are going to assign these IP addresses to R1 and S1. I'm going to click on R1, bring it up here, make the window a little bit bigger, going right to left. Press enter. We are in user exec mode. Type enable to get into privilege exec mode. And then we're going to configure all of our interfaces. That would be these G0s and G01 sub interfaces. Okay. So get into global configuration mode, type config T, then we can go into our first interface. Our first interface is G0/0. Once in there, we can go ahead and set our IP address. Put our IP address, IP space address space 172.17.25.2. And because we're setting that IP address, we have to include the subnet mask. Same thing for an IP version 6 address. When we set that IP version 6 address, we need to include the prefix. That's the slash number for an IP version 6 address. Our subnet mask here is 255.255.255.252. Sets that IP address. Now we can go on to the next interface, G01.10, with our IP address of 172.17.10.1 with 3 255s. Interface G0/1.10 takes it into the sub interface. We can see that by our command prompt. It now changed. It says configuring sub interfaces. We can set our IP address 172.17.10.1 with a subnet mask of 3 255.0, and we get a warning: configuring IP routing on a LAN subinterface is only allowed if that subinterface is already configured as an IEEE 802.10, 802.1q, or ISL VLAN. We need to set the encapsulation first. And that command here is encapsulation. What method of encapsulation are we going to use? I put a question mark, and we can see that it's .1q. Put a space question mark, and then our VLAN ID. What VLAN are we going to tag that information with? And we are tagging it with VLAN 10. Go ahead and set that in there. Now we can go ahead and set our IP address. So IP address of 172.17.10.1 with 255.255.255.0. That takes care of our .10 subinterface. We can go to our .20 subinterface. interface G0/1.20. Set our encapsulation to .1Q and VLAN 20. IP address of 172.17.20.1 with 3 255s as our address. Now we can go on to our .30 subinterface. Interface G01.30. Set our encapsulation to .1Q on the 30 VLAN. Set our IP address to 172.17.30.1 with 255, 255, 255.0 as our subnet mask. We can go on to the .88 subinterface. Interface G01.88. Set our encapsulation to .1Q, and we are tagging it with the 88 VLAN. And the last one here is our .99 subinterface. You can go ahead. Oh, we didn't set our IP address for the .88 interface yet. IP address of 172.17.88.1 with 3 255s. Now we can go into interface G01.99. Set our encapsulation to .1Q and tagging it with VLAN 99. Spell encapsulation right. There we go. Okay. I spelled it corrected finally. And once again, this is the Cisco operating system. If you type in something incorrectly, it will definitely let you know that you did it wrong. It'll give you an idea of where you did it wrong. Right there, it gave me a little caret sign saying, probably right in this area you have a problem. Yep, and a spelling error. I did a spelling error the second time. Now I finally corrected it, and Cisco doesn't say a thing. No news is good news with Cisco. We set our encapsulation to .1Q on the 99 VLAN, and then we can set our IP address to 172.17.99.1 with 255, 255, 255.0. We exit out, exit out. We set all the R1 addresses. Now we need to set the SVI, switch virtual interface, for S1. I'm going to go ahead and click on S1. Make the window a little bit bigger, going right to left. Hit enter. That takes us into user exec mode. Type enable for privilege exec mode. Config T for global configuration. And then interface VLAN 99. Go into that interface. Now we can set our IP address of 172.17.99.10. And it's letting me know I forgot something. I forgot my subnet mask because I'm saying that IP address. Up arrow once, space 255, 255, 255.0. Okay. Now, looking here, I forgot to do one thing back on router 1. We did all the sub interfaces. We put them all on there. But one thing we need to do is turn on the physical interfaces. By default, physical interfaces are turned off on the routers. Virtual interfaces, by default, are turned on. We need to go in and turn that physical interface on so all those sub interfaces are going to work. I'm going to go ahead and minimize the S1 window. Click on R1. I got to log back in. Enable. Config T. I need to go into the physical interface of gig01 and activate that. So interface gig0/1. To activate it, that's no shutdown command. So I do a no shutdown. And as you can see, the physical interface of gig01 went to up, but then all of my other sub interfaces, they also went to up. That takes us through requirement 1. Requirement 2, configure the default gateway on S1. I'm going to go ahead and minimize R1, bring S1 up. You can see right here when I brought that physical interface gig 01 up on the router, it also brought it up here on the switch. Now I need to set my default gateway. Setting the default gateway is not specific to an interface, it's specific to the entire device. I need to get out of interface configuration mode. Go ahead and type exit once, hit enter. Now I can go ahead and set the default gateway. It's part of the IP protocol, so we start off with IP and then default dash gateway, and then we can put our address in here for the default gateway. We get that from our addressing table. We get our default gateway from right here, 172.17.99.1. 172.17.99.1. It sets our default gateway. That takes care of the second requirement. On to the third requirement. Third requirement, create, name, and assign VLANs on S1 based on the VLAN ports assignment table. Ports should be in access mode. Your VLAN name should match exactly. Well, the last part here, it needs to match exactly. So we have to have upper and lowercase where specified, and we need to have the symbols in here. So faculty staff has a /, guest default has some parentheses. We need to make sure we include that and the correct capitalization. Looking here, I'm going to do the create and name as one step because you create the VLAN and then you can name it right away. And then when you assign it to the VLANs and you turn it into an access port, you actually go into ports themselves. So you create the VLANs, you name it, and then we're going to go into the ports, set them as access ports, and assign them to VLANs. Here in our S1 configuration window, I'm in global configuration mode. And so first step here was to create and name our VLANs. To do that, all we do is type in VLAN and then our VLAN number. First one we're working on is VLAN 10, and that's the faculty staff. So VLAN space 10, go ahead and hit enter. Our prompt is now changed here. If you notice that, we are in the configuring VLAN mode. And all we have to do is name it at this point in time. Our name is capital F faculty / capital S staff. You could type exit and then VLAN 20, or you could just type VLAN 20, save yourself a step. I'm going to type in VLAN 20. How do we know that worked? Cisco didn't give us a warning or an error. So that command executed properly. We are now in VLAN 20. The name of VLAN 20 is capital S students. VLAN 30. Create it. Name it. Capital G, guess, opening parentheses, default, closing parentheses. I spelled guest wrong. I'm going to go ahead and correct that while I'm still here. Because if you have a spelling error in the name, you're not going to get credit for it in Packet Tracer. There we go. That's spelled correctly. Go into VLAN 88, name it native, and VLAN 99 management. Name and then management. We have that set. We exit out, exit out. We do a show VLAN. We can see all of our information. Let's just go ahead and verify it. VLAN 10, faculty and staff. VLAN 20, students. VLAN 30, guest and default. 88 is native. 99 is management. That all looks pretty good. Now, next one is we have to go into the ports and assign what VLANs and the access mode. If we look up here, VLAN 10 has ports 11 to 17. We can use the range command, and the range command allows us to specify a range of IP addresses, multiple ports that when we enter in a single command, it applies to all of those ports. Okay, we are in privileged exec mode. We need to get into global configuration mode by typing config T. Now, this is where we get into using that interface range command. It starts off with interface and then range, and then you have to say our starting port, and that would be F0/11, then space dash space to 17. That's what our requirement gives us right here. Go ahead and hit enter. Notice our prompt. Our prompt is now changed. We are doing a range of interfaces. We're configuring in an interface range. Any command we enter in now applies to that range we just entered above there, 11 to 17. First thing we need to do is set it as an access port because we're connecting end devices to this. That command here is switch port. Okay, let's spell it correctly. Start completely over. Switch port mode access. That turns it into an access port. And then we set up what VLAN it is, and that's VLAN 10. That's switch port access, because we're dealing with an access port, VLAN 10. We can now just specify the next range command, and that is interface range F0/. Here's our second information from our VLAN and port assignments table. F0 18 to 24. 18 space dash space 24. Sets our range. Set it as a access port, switch port mode access. Spell access correctly. And then say what VLAN it's part of. And that's another switch port access VLAN, and that is VLAN 20. Once again, we got to spell switch port correctly. Switch port. Then we have one more range we need to specify. That's right here, 6 to 10. Interface range F0/6 space dash space 10. Set that as a access port. So we got switch port mode access. And then what VLAN? That is VLAN 30 switch port access VLAN 30. Switch port access VLAN 30. That takes care of assigning our ports there. That's requirement 3 onto requirement 4. I hope you're liking this episode on practical configuration examples. Leave a comment on what you think about these configuration examples. If you still have a question or comment, please let me know below. You can also visit my website at KevTechify.com for all of my details and how to get these episodes in video and podcast form. Requirement 4 is configure G01 on S1 as a static trunk and assign the native VLAN. Okay, we need to get into interface G01, interface G0/1. Set it as a static trunk. That's switch port mode trunk. Set that as a trunk. Notice we went down, we went back up. We take it down, make the change, bring it back up. And then because it's now a trunk, VLAN 99 is also set. Next thing we have to do is set our native VLAN. As long as we're right in here with our interface of gig01, it's another switch port. We are working with the trunk functionality, so the next word is trunk. Native VLAN of 88. That's what we up here from our table. They're VLAN 88. Gotta spell switch port correctly. And that sets our native VLAN. Once again, native VLAN is for untagged traffic. Sometimes you have legacy old equipment, maybe you have some proprietary equipment that doesn't support that VLAN tagging, 802.1q, where it inserts what VLAN it belongs to. If you have old equipment, outdated equipment, proprietary equipment, sometimes it doesn't support it. If it comes in on a hub for some reason, it won't be tagged. If it's untagged, it goes into that native VLAN of 88. Maybe you have some special security up there. We just need a place to put it. We're going to put it in VLAN 88. The default native VLAN is VLAN 1. We're changing it to 88 here. Okay, that takes care of requirement number 4. On to requirement number 5. Requirement number 5. All ports that are not assigned to a VLAN should be disabled. If we look up here, we have 24 fast Ethernet ports. Lowest number we have here is 6 to 10, then 10 goes to 11 to 17, 17 goes to 18 to 24. We're using 6 to 24, that's the highest one, so what we have to do is we have to set ports 1 to 5, disable them, we have to deactivate them, we have to do a shutdown on them. So it's not a no shutdown, it's a shutdown. And then also, we are not using gig 02. Gig 02 is not listed. Gig 01 is a trunk that goes between our switch and our router. So that needs to be a trunk that needs to stay up. But gig 02, we are not using. We also need to disable that one. And so we can use a range command to cover both of those. A range command can be used for a group of addresses, and they don't have to be continuous. We can go fast Ethernet 1 through 5 and gig 02. How we do that is start off by saying interface and then range. Then you say the first group of addresses. Fast Ethernet 0/1 space to 5. Then you put a comma in there. Then G 0/2. That's the other one we have to disable. That gives us our range. So any command we enter in now applies to these interfaces. We have to disable them. To disable them, we do a shutdown command. That shuts them down. Exit out. Exit out. And we need to do one more thing. We set the default, or we set the native VLAN here on the switch as 88. Now we need to set the native VLAN on the router. If we haven't done that, we need to go in there and do that. We need to set the native VLAN on the router. Right here you can see we did the switch. We set native VLAN to 88. On the router, we have to go in there and set that native VLAN. I'm going to go ahead and minimize S1 here. I'm going to click on R1, bring that up. We got to log in again. Enable config T, and it's VLAN 88, but we're using subinterfaces, so we need to go into this subinterface, and how we set that is when we say what the encapsulation is and what VLAN, we can then say this is the native one. So any untagged traffic put into this VLAN, and we have to go into gig 01. Gig 0/1.88, reset our encapsulation, have it set it to VLAN 88, and then specify native at that point in time. And so we have interface G01.88, and we have to reset our encapsulation. It is encapsulation.1q for VLAN 88, and then I'm going to put a space and a question mark, and then you can mark this here as the native VLAN. And all we have to do is just type in native at this point in time, and it sets that native VLAN. Configure Inter-VLAN routing on R1 based on the addressing table. Well, we've done that all through all of these steps up here by creating the sub interfaces, turning on the physical interfaces, setting up the IP addresses. All of that on R1 set up our Inter-VLAN routing for us. Last step we have to do is verify connectivity. R1, S1, and all the PCs should be able to ping each other and the server. Well, we're going to start with PC1, and we're just going to ping everything from PC1. And I'm just going to ping all of these IP addresses on R1, each interface. I'm going to go through, ping the SVI on the switch, ping the other two PCs, and then ping our server. Starting off, first one, ping. Right here on our first IP address, 172.17.25.2, 172.17.25.2. That successfully works. Go on to the next one. 172.17.10.1. Whoops. 172.17.10.1. That works. The next one is 20.1 at the end. If I up arrow once, I can just backspace, make the change to the last 2 octets to change that to 20.1, and I can ping those. So that was our .20 interface. We'll do the .30 interface. Up arrow once, backspace a couple times, change that to .30.1, the last 2 octets. Those are successfully working. Ping the .88 interface. Up arrow again, change it to 88.1. Those are successfully working. Ping the .99 subinterface. Up arrow once, backspace a couple times, change it to a 99.1. There we go. We are at 4 successful pings. Now we're going to ping our SVI on switch 1, 172.17.99.10. Ping 172.17.99.10. Uh-oh. Might have a problem here. Timed out. Note. Oh, 2 worked, 2 failed. Wow, probably just doing an ARP lookup. IP version 4 does an ARP lookup. What I'm going to do is just repeat that command. Up arrow once, hit enter. All 4 works. It was just an ARP request. Yep, it was just an ARP request that these 2 failed up here. That is successfully working. Let's go ahead and ping. We're PC1, so we don't have to ping ourselves, but let's go ahead and ping PC2. Ping 172.17.20.22. Let's hope we're doing some ARP lookups. Looks like we did. I'm just going to repeat that command. Up arrow, enter. 4 successes. That looks good. Let's go ahead and ping PC3. Ping 172.17.30.23. Hopefully we're going to do an ARP lookup here, and then it'll start working again. 1 failure, 3 working. I'm going to repeat that command. Up arrow, enter. We have 4 successes. And the last computer here we're going to ping is our server. 172.17.50.254. Ping 172.17.50.254. And 1 failure. Hopefully we're doing an ARP lookup. 2. 3. A 4th one worked. Oh, we have 3 failures. That's a pretty long ARP lookup. But notice we're going through this HQ cloud here. There's probably several ARP lookups that had to happen in this process. What I'm going to do is I'm just going to repeat that command here. Up arrow once, hit enter. If all 4 work right away, it's a success. There we go. We are able from PC1 to ping everything. So we have full connectivity. That was Packet Tracer Lab 4.5.1 Inter-VLAN Routing Challenge. It was my pleasure to provide you with this wonderful episode on configuration examples. If you like this episode and you got value out of it, please click that like button, give a 5-star rating, leave a comment. This all helps me bring you more great content. Please take a minute to subscribe to my channel. All my socials and contact information are on my website, KevTechify.com. There you can find out how to get all these episodes in video and podcast form. Thank you so much for watching this episode of my series on practical configuration examples for the CCNA. I've created 4 wonderful playlists for you on the CCNA. These episodes, I go through all the concepts that Cisco calls out for the CCNA. Once again, I'm Kevin. This is KevTechify. I'll see you next time for another great adventure.